And yes, welcome everyone. Happy Valentine's Day. I'm so happy that we've got Greg Hahn with us today. So Greg is the VP of Exploration and Director of Arizona Gold and Silver, who are exploring the largest historic gold-bearing district in Arizona. So it was last explored extensively back in the 1980s. So it's going to be amazing hearing from Greg today about how the application of new science has led to the discovery of a significant low sulfidation epithermal gold-silver deposit. So thank you so much for joining us, Greg. I'm really excited to have you on today.
Well, Jessica, thanks for having me on this venue. I look forward to looking at some of the other presentations that have run before and are coming up. So I'm going to tell everybody about what we think is the largest low sulfidation epithermal gold-silver deposit known in Arizona. We've just started working on it over the last 3 or 4 years, and it's still growing. So it's becoming something rather significant. This cover slide here is of what we call the Red Hills. The Red Hills are a highly altered package of volcanics that we'll show you during the course of this presentation, probably represent the heart of the epithermal system here at the Philadelphia project. We set up Arizona Gold and Silver Exploration to explore for precious metals in Arizona, which is situated roughly halfway between the largest gold-bearing district in North America, which is in Nevada, and the largest silver-bearing district in North America, which is to the southeast of us in New Mexico. Everybody knows Arizona is well known as a porphyry copper district and is the largest copper producer in North America, but very less well known for the precious metals. And as you can see in the slide here, gold tends to be more enriched in the northwest towards the Nevada Gold District and more silver rich in the southeast towards the Silver District. So looking for gold, we want to be in the northwest part of the state. So with that in mind, we went to the northwest part of the state. This is the Oatman District, located in Mojave County, northwest Arizona, right on the state line with Nevada. You can see Laughlin, Nevada, across the Colorado River from Bullhead City, Arizona. This is a past producing district. It's the largest past producing district in Arizona. Produced over 2 million ounces of gold and will produce probably another million ounces with reserves that are identified and or in process of being reported. The primary deposit was down at the Oatman mines. It's a low sulfidation, high grade epithermal vein system, produced nearly 2 million ounces on its own, an average grade of about 0.8 ounces per ton. To the north of it is the Gold Road mine, which is currently on care and maintenance. It was operated up until a few years ago, and it is also a high grade vein with from underground production. To the northwest of that is the Moss mine, which is operated by Elevation Gold. It's currently in production. It's a large low-grade open pit deposit, and both of those deposits are adjacent to our property position. Our project is the Philadelphia project, located to the north of the Moss mine, and we'll talk a little bit more about that for the rest of this talk. A little bit on the geology. One of the things I was exploring this district back in 1984. It was a rush. Claims were staked across the entire district, but the geology wasn't well known. In the time since we were working on it in the 1980s, the geologic maps have been published and more technologies become available that can be used to understand the district. But this is, in general, the depiction of some circular features that we think are caldera structures that migrated from the north, the oldest being about 19 million years old, to the youngest, which is about 15 million years old to the north. And the Philadelphia project sits within the youngest circular feature or caldera in what is predominantly a rhyolite volcanic complex. This whole system has been cut by younger extensional faults, detachment faults, and large granite complex to the west in California and in Nevada probably represents the roots of the volcanic system that we're exploring, which has slid off of that large plutonic complex to the west. Now, the Arizona Geological Survey has published some very nice geologic maps that can be used to try to understand the general geology in a gross sense. That wasn't in existence in the 1980s, and so everybody was pretty much flying by the seat of their pants with a lack of understanding of the geology. If you zoom in on our project and property position, we're in this semicircular feature, which has been cut off to the west by this roadside detachment fault. Looking at flow domes that form kind of the southwest margin of the caldera, and then a keystone graben that cuts across the middle of the caldera, within which there's significant amount of alteration. What you're looking at here is some hyperspectral imagery alteration colored according to the legend that you see here. And that represents a very strong locus of hydrothermal activity in the core of the keystone graben, as well as along structures to the north of the keystone graben. Just looking at the hyperspectral imagery, the greens on the left represent chloride epidote alteration in the footwall of the system. The yellows, the oranges, and reds represent phyllic and argillic alteration in the hanging wall of the system. The area that we've been drilling is just this small circular area here to the west, which is hanging wall to the mineralization that we've encountered to date. This area represents prime exploration opportunity as well as the area to the north. But for now, we haven't really done much work in those areas, just noting that there's a significant amount of alteration in this district that has never been explored. The background to these slides, a lot of these slides is pan concentrate of VG, visible gold, that we get out of our drill cuttings, and we just thought we'd use that to highlight the abundance of gold in the system. But zooming in on the interior of the western side of our land position, we're looking at patented claims in the rectangle in green, within which you can see some discontinuous red lines that represent outcrops or subcrops of high-grade epithermal veins. Those veins continue well to the south. They actually have a strike length of over 3 kilometers. And in the heart of the system, there is this large heart-shaped orange-red alteration zone, which we think represents the heart of the system and the locus of a bulk tonnage target that may have fed these epithermal veins along a major fault structure there. The property was operated from the late 1890s, maybe even in the 1880s, to about 1935. You can see underground mine workings here that were developed on 4 levels with significant open stopes developed throughout the length of the underground workings. There are very good records from the Bureau of Mines from production back in those years, and cutoff grade was really described in dollars per ton. It was $8 per ton was the cutoff grade. Gold was trading at $20 an ounce, so $8 per ton represents a 0.4 ounce per ton cutoff grade. So all of these open stoped areas were running greater than 0.4 ounces per ton on this high-grade vein. Why it stopped to the north and the south is a mystery to those of us who looked at it until we were able to drill it, and we can tell you it doesn't stop either to the north or the south. We'll demonstrate that in a bit. This is an example of the targets that we've identified on the heart of the patented ground and the extensions to the north of it. The red dots are intercepts that we've drilled to date that are greater than 0.25 grams per ton over mineable widths. The yellow workings there you can see on the old mine workings ellipse. The large area to the south of it is the Resaca target. There are no drill holes in that target. We have excellent surface geochemistry and high-grade veins on both sides of it, but has never been drilled to date. South of that, Meridian Gold drilled some holes in the 1980s. What I should point out here is to the north is a new 4-lane highway. That is Arizona State Highway 68. This paved axis that runs down through the heart of the property was Arizona State Highway 68 in 1984 when I visited the property. And Meridian drilled a few holes on this hill to see if there was enough resource above the highway that they could develop. Concluded that that was too small, given the right-of-way across the highway. It was just impractical to try to develop it. And that's what discouraged a lot of people from exploring this property until the state decommissioned this highway and rerouted the highway to the north around the property. This now is our paved driveway, and we've actually set up drill rigs on the pavement, which we don't get to do very often in this business. But here's the large alteration zone that we think is the heart of the system. We've drilled about 1.5 kilometers, maybe 1.75 kilometers to date, with gaps in between, and we'll look at that as we move along. But we've had excellent results on the south end, excellent results in the interior, and we need to finish drilling in the gaps in between, which we'll look at in a bit. So far, the strike length is roughly 3 kilometers. We've drilled about 1/2 of that to date. Highest grade intercepts have been 72.5 grams per ton across 1.5 meters. Best intercepts have been 10.5 meters of 10 grams plus 80 grams of silver. Average of about 40 holes now in the high-grade veins is 3 meters of just under 9 grams per ton and 42 grams per ton of silver. But there's also a bulk tonnage target that is adjacent to and peripheral to the high-grade veins. There we've had some very attractive intercepts of 100 to 115, 16 meters of 1.3 to 1.6 grams per ton gold, which is wide open to the south and to the east and represents a bulk tonnage target on the property. So we'll look at details of all of that a bit. First, I want to review the model that we're pursuing, which is based on the Oatman production from back in the turn of the century to the 1930s. The best deposit there was called the United Eastern Ore Body, and it has virtually no surface expression, just an alteration at the surface with no vein expression, no strong geochemistry. There'd be nothing on the surface that would entice you to drill that target. Why the shaft number 1 was sunk is a mystery to me, but at the 150 level, the vein was encountered, but it was only 4 feet of about a gram. It went down another 140 feet, and then it became a meter of about an ounce per ton. And it wasn't until you're down close to 450 feet below the surface that the vein really blossomed out into something close to 10 meters thick and over an ounce per ton gold. And it continued that way for about 1,000-foot depth. So this is the target we're chasing. This is roughly the level of exposure that we think we've drilled to date based on the surface geochemistry, the surface alteration, and the intercepts we've had along the strike of the vein to date. This information was known back in the 80s, of course, when we explored this in the 80s, but what wasn't known very well was the Buchanan model for epithermal vein deposits, especially low sulfidation epithermal vein deposits. And this is a embellishment on the model of Buchanan from 1981. Remember, this was being explored in 82 and 84. So this was a relatively new concept that wasn't well understood back in the early 80s. But I want to point out some of the features here that are important in identifying where you are in an epithermal system. I've circled these little geyser eruptions that are on this model. They're important because we think we can see evidence of those in the rocks at the surface. I'm going to point out the stockwork mineralization here, which is shown in this cross-hatched red veining, and then point out the veins converging down into what is interpreted as the high-grade zone. Over to the right here are the minerals and the gangue minerals and the vein textures that are characteristic of various levels of the epithermal system. And I've circled here calcite as the dominant gangue, lattice-bladed calcite, and chalcedonic quartz replacing bladed calcite. We'll show you evidence that this is where we are in the system, and we have yet to get down into the heart of the system where we expect the grades and the thickness to really blossom out. One of the technologies that we have at our availability is hyperspectral imaging, which wasn't around back in the 1980s. On the left-hand side is just a normal photographic image of the core. It's all busted up. It all looks the same. Lithologies don't change much across that area. But if you look at mineralogy in shortwave infrared, you see some dramatic changes in color. And the greens represent smectite. The purple represents montmorillonite. And if you look at the column of this entire drill hole, we have some overlying volcanics, which are the red hills that I pointed out at the beginning of the talk. They are dominated by montmorillonite. There are little blips of precious metals throughout the top of that interval that suggests something is leaking up through the volcanic cover. And when you get to the bottom of that volcanic cover, the iron oxide content really skyrockets. Once you get down to a certain depth, you notice a dramatic change in dominantly montmorillonite in purple to dominantly smectite in green. That is very well-defined clay mineral transition in geothermal systems and defines the 150-degree C isograd, the top of the boiling zone. I think it's important to note that at that transition, as soon as you get below that transition, you get this dramatic spike in gold and silver mineralization, which is gold and silver precipitating out at the top of the boiling zone. and then gold and silver mineralization continuing at depth until you get down to this granite footwall here, which is propylitically altered, is dominant by epidote chlorite. So this is an exploration guide. If you're on the top of a epithermal system with a strong boiling zone, you can tell more or less where you are in the system by what kind of mineralogy you're identifying at the surface. And that's why the hyperspectral imaging has become such an important tool for these deposits. Well, we were still puzzled by some of the features that we have on the property. So we brought in Dr. Stuart Simmons, who some of you may know. He spent some time at University of Auckland and in New Zealand. And he's well known as probably one of the world's premier experts on geothermal and epithermal systems and the geology thereof. Behind him and our project geologist, Mark Stengel, is an enigmatic outcrop. It's a breccia made up of predominantly quartz clasts and rhyolite clasts. The clasts are very well sorted and they're rounded. They've been milled. They've been sorted. If you sample this, you get some weak gold mineralization. If you sample the quartz clasts in it, you'll get stronger mineralization. But as of the time we came into the property and acquired a lease on it, this had not been drilled. But Stuart puzzled over it for a while, and I noticed he put a presentation on GeoHug a while back on the Waiamu geysers in New Zealand. And he brought that up when he saw this outcrop. He says, I think you're looking at the throat of a geyser. And everything, all the ejecta falls back down into the throat and is sorted due to the fluid dynamics and the aerial eruption of the particles flow back down into the throat. So we like that explanation, and we stepped back to where I was taking the photograph from and drilled the first hole into that feature, which we call the shark fin for its geomorphology. And what you're looking at here is carbonate cemented breccia down to this core block. And from that core block down, you're looking at yellow quartz replacing bladed calcite in the system. This is the boiling zone, the top of the boiling zone. Everything above here is vapor phase carbonate mineralization. This grades about 3 grams per ton gold. Everything below it is yellow quartz replacement of bladed calcite. This grades about 30 grams per ton gold, right across that transition. So we're definitely at the top of the boiling zone based on that interpretation, and we have the entire boiling zone below us yet to explore. Internal to the yellow quartz are fine particles of visible gold, as witnessed by the pan concentrates over here on the left. Very fine, though. They're 100 to 150 micron sized particles. We'll look at a couple of cross sections across this complex, and this is the high-grade vein in outcrop or subcrop as it tends down the heart of the patented claims. We'll look at a section here, sections here, and another section down here to see what the character of the mineralization looks like. This is the cross section at the north end of that previous slide. This outcrop here is all, I'll show you pictures of this in a minute, but it's all Stockwork quartz with high-grade veins at both the hanging wall and footwall contact of it. We drilled a hole underneath that outcrop, and on average, it's 50 meters of almost 3 grams, about 6 grams per ton gold. The hanging wall vein here, 1.5 meters of 18 grams, and a footwall vein here, 1.5 meters of 72.5 grams. Drilled another hole from that location, and it continues. Not as spectacular a grade in the high grade and footwall veins, but still the geometry holds together well. Our landlord was doing some excavation on the surface, and he uncovered an old drift. An old drift went right through this system, approximately where I've shown it on this section. It was covered up by some surface material that had buried it probably in the 1930s. No one had seen this in the last 100 years until he uncovered it. You definitely see a good high-grade vein at the surface, at the portal, actually. And then you go through a spectacular stockwork zone until you get to the footwall vein, which is an attractive feature with abundant fluorite in it. And then you get into some low-grade mineralization in the altered granite below it. So we have some good evidence of some vertical continuity here that we'll pursue with additional drilling. This is a slide in the middle of the location map that I showed you. This is a little more densely drilled. Very good continuity on the high-grade vein at the top of the Stockwork zone. Stockwork zone contains the heart of this high-grade vein sandwich. And in this section, there's a footwall vein there that's all carbonate cemented breccia, but we haven't gotten down into the boiling zone until we got to this very last hole here, which got out of the carbonate and into the chalcedonic quartz, which we now think is at the top of where fluid and gas escaped up the footwall of this complex. Excellent grades in here. We're looking at 33 grams over a meter. There's 16.5 grams over a meter. And then maybe another 17 grams over a meter or so. So it's a robust system, and given that we're at the top of the boiling zone, we think there's opportunity for improvement as we go down into the heart of the boiling zone. To the south, the character of the system changes significantly. This is where we're getting into the Red Hills cover that we alluded to at the beginning of the talk, and that we showed the hyperspectral imaging over. But we do have the high-grade vein in here, but instead of having the high-grade vein at the top of the mineral system, it has a fair bit of low-grade, and by low-grade I mean 1 to 1.5 gram material covering it in the hanging wall volcanics. There's more gold bleeding up through the volcanics here than there is elsewhere on the property, and as a result, you get this nice 100+ meter thick interval of over 1.5 grams per ton gold and 7 grams per ton silver. It's open to the east. It's open to the south. We're currently permitting holes to drill out of the patented ground onto public lands here. And I just got word today that our EA was accepted and will be published on March 4th for a 30-day public comment period. So we're probably not far away from getting the permit to drill these holes and chase this system to the east and move it to the south. This is our model, and I've drilled volcanic hosted flow dome complex precious metal systems for the last 25 years or so of my career. And this is a very common model that you can apply to these systems. The flow dome acts as a pressure cooker lid, and everything builds up. The hydrothermal system is fed from underneath. It builds up underneath until it overpressures, and when it does, it explodes, and you get hydrothermal breccias along the footwall contact up structures that may be cutting the flow dome complex, or along the margin of the flow dome complex, and you get fractures up through the flow dome that evidence the presence of something underneath it. To date, we've just drilled these holes off to the west flank of this flow dome. These are the locations of the BLM holes that are being permitted. These are the locations of additional holes we would drill if these are successful holes. But this is an example of the magnitude of the target we're chasing, with a high-grade feeder zone underneath it that represents the feeder of the epithermal system. In plan view, this is what we think the system is laid out. The altered flow dome complex is the heart of the system and the source of the gold and silver. Gold and silver flowed out on the marginal fault here called the Arabian Fault until solutions kind of dissipated to the north. It did likewise the same thing to the south until solutions dissipated to the south. You can't find a vein continuity down here. You can't really find a vein continuity up here. The geochemistry changes dramatically. This is a very low silver gold ratio. This is a much higher silver gold ratio in here. And by the time you get out here, you're looking at high beryllium, which is a light ion lithophile element that gets carried away to the extremities of the system. So we're pretty confident this is the heart of the system. We just need to get in there and get some drills burning so we can see what it looks like beyond those 100-meter intercepts. And to the south, as I said, the vein continues. Good-looking vein textures are up to 10 meters thick for another 1.5 kilometers to the south. They stand out boldly in outcrop, but these are dominantly carbonate. Some of them are even banded carbonate, telling us that we're above the boiling zone in the vapor phase of the fluid that is generated by the epithermal system. Well, to test our concept, we ran one CSAMT line over the Red Hills. These are the Red Hills. This is the result of the CSAMT anomaly. This is a large resistivity low underneath the entire Red Hills, representing what we think is the mineral system underneath this alteration cap. We haven't had a chance to really test this properly. So with the permits from the BLM, we'll be able to stick some holes into this and see if indeed this interpretation is valid. But this is the high-grade vein along the Arabian Fault, and this is what we've been focusing on to date with the Stockwork mineralization sandwiched between the two high-grade veins. This is the back of the photograph, the back of the new adit that was discovered. It's Stockwork quartz and hematized granite and fine-grained rhyolite. This is a photograph of the Stockwork zone that is footwall to the hanging wall vein, high-grade vein. I've kind of annotated where the vein is here in this photograph. The Stockwork zone continues for about 35 meters behind the hanging wall vein, and then there's a footwall vein beneath it that you can't see in this photograph. There's a sense of a fabric in the Stockwork quartz here, but when you apply a attribute filter to it, it looks like it's pretty chaotic. It's hard to see a pattern, and this looks like a can of worms, and it's a bit enigmatic to us why this doesn't have a more plainer fabric, given that it's bounded on the hanging wall and the footwall by two prominent fault features. I think it represents either hydrodynamic brecciation in here and complete permeability between the clast fragments, which also may have been milled a little bit to round them up as a tad as they've been rolled in the breccia. This is a photograph of a cleanly washed photograph outcrop of the high-grade vein, the hanging wall vein. You can see beautiful bladed calcite textures in here that have been replaced by yellow quartz. This outcrop ran 9 grams per ton across 2 meters. So it's a pretty good representation of what the high-grade vein looks like high in the system. This is what the Stockwork zone looks like in core. Quartz veins go every which way. It's impossible to try to make much sense out of the orientation of these veins. And having seen the photograph from the surface, you can understand why there's no systematic fabric to the veins in the Stockwork zone, although they do carry appreciable gold. We've started some metallurgical test work to confirm what we inherited with the project. We've got very limited column leach test work done back in the 1980s, ran out for about 18 days, had excellent extractions up to about 18 days, but then for one reason or another, unknown to us, the columns were terminated. So we projected the leach rate. It was leaching at anywhere between 0.3 and 0.5% per day, projected that out, and we anticipate we'll be getting 70+% extraction over 100+ days. We currently have duplicates of these sample sites under leach with McClellan Labs in Sparks, Nevada at these different crush sizes. And we only have 4 days of solution back, but we're already at about 30% extraction under 4 days of leach. This is a subsurface view of drilling completed to date. We've completed 112 holes to date. We also have 15 meridian holes in the database. And you can see these large gaps in between our drill holes. Most notable here is that there's a pronounced plunge to the mineral system as from north, where it dissipates and is probably eroded off, to get to the south, where it is plus 100 meters thick down here. And it's open to the south and out to the east, as I showed previously. But we have these gaps that we did not drill because of restricted access issues at the time. So our plan is to fill in these gaps and before we complete a resource estimation on what the tons and grade of this mineral system are, at least within what we've drilled to date. These are some of the BLM sites that we are in the process of permitting that will go for public comment here in the next couple of weeks. We'll drill a total of 20 holes from each of these pads to try to flesh out what the mineral system looks like underneath this flow dome complex. These holes here are the ones that ran 110 meters of over 1.5 grams per ton. So this is our bulk tonnage target that we look forward to drilling. And when all is said and done, about 40,000 feet of drilling is complete. We'll have all of these holes in green completed, and we'll be able to estimate what the resource is between the south end of the deposit and the north end of the deposit, rather, and the south end, where we have terminated our drilling to date. It still remains open to the south, but this is as far as we will get for now. So what are we looking for? Bulk tonnage target based on the CSAMT survey is about a half a kilometer long, half a kilometer wide. We know it's about 100 meters thick based on the drilling we've completed to date. Using a tonnage factor of 2.5, we're looking for about 60 million tons at a target grade of 1 to 1.5 grams, or 2 to 3 million ounces of gold. As I said, we have 2 holes in this target area that already average 110 meters of 1.45 grams. We also have 80 holes in Stockwork peripheral to this that average 45 meters of 1.34 grams. So that'll become part of the calculus when we do our resource estimation, hopefully at the end of this year. On the high-grade vein side, we have 1,500 meter strike. I think we can chase it. We've already chased it down 350 meters, and it's just now getting out of the calcite zone. So we think we can chase this down 400 to 500 meters, averaging 3 to 4 meters thick. Another 2.5 tonnage factor gives us 4 to 8 million tons in the target, grading 9 grams per ton and 30 grams per ton silver. We've already have 40 holes in the target, and our average grade is 9 grams per ton across 3 meters and 45 grams per ton silver. So we have these 2 targets that we think would be very attractive once they're adequately drilled and quantified. And one of the things that's unique in this old district is there are 2 operating mines that are neighbors to us, one of which is on care and maintenance and the other which is running out of feed. This is the Gold Road facility to the south of us, or southeast of us. This is the Moss Mine facility to the south of us. They represent some attractive opportunity. That Gold Road Mine and Mill is a permitted 500 ton per day cyanidation plant, 12.5 miles away by highway truck haul. The Moss Crushing and Heap Leach Processing Facility is an 8,000 ton per day, 3-stage crushing, conveying, and stacking operation, with currently about a 2 to 3 year mine life remaining. Now, it doesn't mean they can't find some more in the meantime, but we hope they do. But one's out of feed, the other one's soon to be out of feed, and we think we may have feed for both of them, one or both of them, which represents a possible consolidation opportunity once our mineral resources out and we're able to quantify the engineering and economics of the synergies of the 3 properties. So what's our plan going forward? As they say in the oil and gas business, drill, baby, drill. There's no way to define this resource other than by drilling. So we have 20,000 feet, 7,000 meters planned annually for the next 2 years. Anticipate a maiden resource calculation the fall of this year. We've just started some metallurgy. We've actually done a fair bit of vegetation leach tests on the high-grade vein material, and it leaches like a charm. It's 95 to 98% recovery, but we haven't done the column leach test work on the Stockwork yet, and that's what's underway currently. Ultimately, we think we can go to a preliminary feasibility study once the resource is quantified and the metallurgy is quantified, and we can look at the economics of someone taking advantage of the existing facilities. And I don't want to forget the upside here. You know, the astro imagery that we have, hyperspectral imagery that we have, is 30-meter resolution. It's very crude, it's coarse. It tells us there's a lot of smoke out there, but we need to refine that. So there's commercially available satellite imagery that will get down to 2-meter resolution, give us more mineralogy. We'll acquire that data this year, do some target identification, ground mapping, and truthing of the targets, and then sampling to verify the targets. But we think there are multiple targets out to the east that can be quantified based on the hyperspectral imaging. So with that, I'll close, leave the slide up for those who might want to take a look at contact information. It's arizonagoldsilver.com. Mike Stark is our president and CEO. You can be contacted for corporate questions, and I can be contacted for any technical questions anybody may have. Of course, I'm available now to answer any questions.
Thank you so much, Greg. That was really awesome. So thank you so much for taking the time.